Hello, well, good evening, ladies and gentlemen, and welcome to this evening's keynote address. My name is Peter Gallagher. I'm a solar physicist, a space scientist here in Trinity College, Dublin, and I'm particularly proud and very excited to be introducing this evening's speaker, the administrator of NASA. Early in my career, I had the great honor of working at NASA's Goddard Space Flight Center, and so at one point he paid my salary. So it's great to have him back here to give this evening's keynote presentation. When you read this man's CV, you can see the hard work and determination and ambition that he has in his personal life and his work life. And I think it's clear that that's translated into the way NASA as an agency operates. They are ambitious, they do hard things, and they don't take no for an answer. And today at lunchtime, Major Bolden gave a public lecture, and it was a really inspiring lecture. And it wasn't just about the technology and about the spacecraft. It was about science, technology, engineering and mathematics. It was about the fundamentals of this and exploring the universe using those. So it was very, very, very moving. So to tell you a little bit about this man, he started off in NASA, but spent quite a lot of his career working in the military. He was a pilot in the military and spent a lot of time working as a pilot. He then became an astronaut. What a job. And went into space 4 times, twice as a commander, and he was responsible for putting the Hubble Space Telescope into space. And really, the Hubble Space Telescope has profoundly affected our understanding of the way the universe works. So what a legacy to have. So without further ado, I'd like to invite Major Bolden to come and give his keynote address.
Thank you.
Thank you.
Thanks so very much. Thank you. Thank you all very much. Thanks very much for the kind introduction, and I want to thank you all for the opportunity to be here, first of all, and be a part of this unique and important conference. I believe that there's nothing more important to us today than our ability to grow our individual economies or solve global problems, than our collective commitment to continue making adequate and smart investments in science and technology. President Obama has said, and I quote, "Whether it's improving our health or harnessing clean energy, protecting our security or succeeding in the global economy, our future depends on reaffirming America's role as an engine of scientific discovery and technological innovation," unquote. The President's 2013 budget reflects that commitment, even though these are very tough economic times in the U.S. as well as everywhere else. His budget for next year proposes $140.8 billion for research and development, an increase of $2 billion or 1.4% over what we asked for in 2012. Now, I have to remind you, that is not NASA's budget. I don't want anybody to get excited, okay? That's the research and development budget from numerous agencies across the government. The U.S. Congress is currently debating the final amount for our investment. I suspect that many of you here are involved in similar funding debates, but the historic importance of science and technology is beyond dispute. From Gutenberg's invention of the printing press in the 15th century to Edward Jenner's 18th century development of smallpox vaccine, from Galileo's groundbreaking astronomical discoveries to Steve Jobs' inventions that are connecting the world in amazing new ways, science and technology have been synonymous with human progress. I'm proud to lead one of the world's most innovative and historic technological organizations, America's National Aeronautics and Space Administration, or as most of you know it, NASA. As most of you know, NASA has a long history of international cooperation across a variety of space activities. In fact, cooperation with other nations and groups of nations in the peaceful exploration of space was envisioned as a key element in the legislation that created NASA all the way back in 1958. While we're proud of NASA's global leadership, we are also mindful that the scientific and human spaceflight achievements of the past half-century would not have been possible without international cooperation. There's something intrinsically unifying about humankind's exploration of the heavens. Beyond the scientific and economic benefits of launching into space, of literally leaving this planet, I can tell you that when viewed from orbit, our borderless Earth inspires a sense of humility, unity of humanity, and wonder. As the great British astronomer Sir Fred Hoyle said in 1948, and I quote, "Once a photograph of the Earth taken from outside is available, a new idea as powerful as any in history will be let loose." How true he was. I firmly believe that the original picture of our blue planet from the vantage point of the Apollo 8 crew returning to Earth from their trip around the moon forever changed humanity's perspective on our planet, and in my estimation was very possibly the origin of the modern-day environmental movement. President Obama has also made space exploration a key element of America's commitment to building a more peaceful world. Upon taking office, he said, and I quote, "As president, I will establish a robust and balanced civilian space program. Under my administration, NASA will not only inspire the world with both human and robotic space exploration, but also will again lead in confronting the challenges we face here on Earth, including global climate change, energy independence, and aeronautics research. In achieving this vision, I will reach out to include international partners and to engage the private sector to amplify NASA's reach," unquote. In his speech at the Kennedy Space Center April 2 years ago, he said, and I quote, "No longer are we racing against an adversary. In fact, what was once a global competition has long since become a global collaboration," end quote. I believe that the success of our modern space programs will be judged in part on how well we continue to make space exploration about global partnership, particularly since it is clear that no one nation can do it alone, and the benefits to be gained are for all humanity. It's a very exciting time to be involved in space exploration. The retirement of America's storied space shuttle last July, after 30 incredible years of flight, represented a bittersweet time for NASA. But the next great era of space exploration is quickly taking shape. In fact, our most recent call for astronauts drew more than 6,300 applications, the second highest we have ever had. Some from this group will become the NASA astronaut class of 2013. They're going to be the ones who will pioneer new ways of reaching space on commercial vehicles and possibly travel to an asteroid and lead the way for those who will go to Mars in the 2030s. And I was privileged to talk with some of the young Irish kids that I told this morning if they study really hard and work real hard, I hope that they're along with at least one of my 3 beautiful granddaughters in becoming the first humans to set foot on Mars. There is so much going on at NASA these days that it would take up this entire conference to cover everything. So I'm going to limit my remarks tonight to 3 things that may be of particular interest to this audience. First, the research and science occurring on the International Space Station. Second, the impact and future potential of our investments in technology. And third, NASA's agenda of ongoing and planned scientific missions. The ISS represents our toehold to the rest of the solar system. What we learn there is going to make it possible for us to venture farther. It will help us become a truly spacefaring people. Already, we have had people continuously on orbit each and every day for more than 11 years. Just the thought of this would have been science fiction when I was a child. Not only is the ISS the largest, most complex international scientific and engineering program in history, it is a test bed for future technologies and systems and is a tangible symbol of unprecedented international cooperation. The International Space Station is also a world-class laboratory in which full-time research is conducted. More than 400 scientific studies were conducted on station last year in an array of disciplines, not just those related to human health. There are probably 5 to 10 investigations going on any given day aboard ISS. These studies are proving helpful with everyday problems of people of all ages here on Earth, and are also applicable to our astronauts on long space voyages. We're learning a lot about the human immune system, inner ear response and balance, visual acuity changes, and bone density loss, for example. Now that its construction is complete, we expect more partnerships in the future with academia, industry, other U.S. agencies, and as I mentioned earlier, other countries to help bring it to its full potential and fully utilize this incredible investment. In addition to all the science and research on human health that has been and continues to be conducted on the International Space Station, perhaps its most profound historic achievement is how it continues to demonstrate that many nations can work together on a project of enormous scope, complete it, and then keep it going. 15 nations contributed to the development and assembly of the International Space Station, and even more are or will soon become involved in the program through their utilization of this amazing research facility on orbit. On May 31st, 2012, an American company, SpaceX, successfully completed the historic mission that made its Dragon spacecraft the first private vehicle in history to visit the International Space Station. Later this year, Orbital Sciences Corporation, another commercial entity, is planning to conduct its first demonstration mission of a similar cargo resupply capability. By 2017, we at NASA are planning to rely on American companies for crew transportation and rescue services for low Earth orbit activities. NASA is currently working with the private sector to incentivize companies to build and operate safe, reliable, and cost-effective commercial human space transportation systems. The economic benefit of this public-private partnership is one of the reasons that it will be a key component of our future. As I've said many times, every dollar we spend on space exploration is spent right here on Earth. Building a strong commercial space sector represents good jobs and innovation and pushes the envelope for our capabilities. The second area I want to talk to you about is NASA's new space technology program that currently involves more than 1,000 projects that are developing the technologies we will need for tomorrow's missions. In the nation's laboratories and test chambers, NASA is driving advances in new high-payoff space technologies and developing and maturing broadly applicable technology in areas such as in-space propulsion, robotics, space power systems, deep space communications, cryogenic fluid handling, and entry, descent, and landing, all of which are essential for exploration beyond low Earth orbit. We're targeting a launch of a cryogenic propellant storage demo in 2016. Our current budget provides for this type of work, and projects like the 3 technology demonstration mission proposals we selected this past year to transform space laser communications, deep space navigation using atomic clocks, and in-space propulsion capabilities, including solar sails. Finally, NASA's commitment to science remains strong. We'll be at Jupiter with Juno and Pluto with New Horizons before you know it. Not to mention Dawn's flight to the dwarf planet Ceres, which will begin when it leaves the asteroid Vesta this summer. I hope many of you have seen the amazing results from Dawn as it has continued to send us data about Vesta itself. Much of this is unexpected data that will help inform our future missions to asteroids with humans. Information is still flowing in by the terabyte from Hubble, the Lunar Reconnaissance Orbiter, the Mars Reconnaissance Orbiter, the Solar Dynamics Observatory, Cassini, Swift, Cassandra, Fermi, and many others. Kepler is documenting an ever-increasing number of exoplanets, showing that our solar system is just one of countless others. The James Webb Space Telescope is being developed for launch in 2018. As the successor to the Hubble Space Telescope, Webb will allow us to continue to revolutionize our understanding of our universe by peering across space and back in time to the formation of the first stars and galaxies. I'm personally very excited that the Mars rover known as Curiosity is on schedule to land on Mars in August. It will demonstrate precision landing technology, enabling us to probe the mysteries of the red planet in unprecedented new ways. This mission is also an excellent example of the synergy we're trying to nurture between exploration and science, as the rover performs amazing research using the most sophisticated suite of tools we've ever been able to send to Mars. You know, you can develop all the technology we want, but in the final analysis, this is all about people. It's about making life better here on Earth, about improving the human condition, expanding our knowledge, and expanding our partnerships across Earth in pursuit of a larger goal that none of us can accomplish on our own. We have numerous demonstrations of this right now, from the International Space Station to the Surveyor program, where scientists around the world use space data and their own ground-based observations to help us better understand the increasing demands upon our planet's resources, as well as to predict Earth's accompanying changes. Everywhere I go, I see the fire in the eyes of students who are just learning how important science, technology, engineering, and mathematics are to understanding our world, and how they can make a real difference by pursuing those career paths. So to me, the future looks quite bright. At the end of the day, it's people from around the world sitting across the table from one another who must decide if together we can bring a complex mission of exploration of our universe to a successful completion. I saw potential of this cooperation firsthand when I commanded NASA's first mission to planet Earth, Atlas I, with Belgium's first ever astronaut, Dirk Vermeulen. We had a complement of 13 international experiments to study our sun and Earth's middle atmosphere in ways never before accomplished. It was displayed to me again 2 years later, when I was privileged to command the first joint Russian-American space shuttle mission with a Russian cosmonaut, my friend Sergei Konstantinovich Krikalev, as one of our mission specialist crew members. The relationships we developed on those missions and others served as precursors to our extremely successful cooperation on the Russian space station Mir and ultimately on the International Space Station. Since NASA was founded 52 years ago, international cooperation has been one of the cornerstones. We have entered into about 4,000 agreements in that time, with more than 120 nations, and touching almost every aspect of NASA's activity. Right now, NASA has 535 active international agreements, conducting some form of ground-based or space-based research linked to every continent and working with nations around the world to develop and implement the next generation of space exploration missions. This cooperation is the definition of win-win, bringing multiple benefits to everyone involved. I want to leave you all with one thought. America stands ready to lead this next era of space exploration and welcomes the support and participation of our international partners in achieving these ambitious goals. NASA's vision is to reach for new heights and reveal the unknown so that what we do and learn will benefit all humankind. Space exploration strengthens us all, not only with the new discoveries we make, but with the numerous technologies that are developed, with applications directed toward improving life here on Earth. Besides that, it brings us together as one world. I look forward to meeting the great challenges ahead and doing it in partnership with folks such as all of you here in this forum. That's our challenge, and I believe this is our moment. Thank you all very much, and I think we're going to open it for questions.
I think your mic should work, so you can walk around.
Okay. Great.
So Administrator Bolden has kindly agreed to take a few questions. So if you'd like to put up your hand and wait for a mic to come to you, and then you can ask your questions. There's a question down here in the center.
Sorry, it was a very interesting talk, but I just wanted to ask, you say in 2017 the public-private partnership will mean that NASA is very dependent on these private companies. Is there any concern within NASA that now that you have private enterprises being a key part of future strategy, that we'll say gain for profit, profit gain becomes more part of the goal than strategic or scientific gain, that in fairness, private companies will not have aligned goals always with NASA?
It is not a concern for me, and I don't think it's a concern for the agency, because we've been working with private industry for more than 2 years now, helping them understand what our requirements are, what our specifications are, and everybody has in hand all those requirements and specifications. And our intent is not to deal with a company that's not aligned with our goals. So the good thing and the bad thing is that right now we're the #1 customer. So, you know, if you don't satisfy, in business, if you don't satisfy the needs of the customer, then they take their business elsewhere. And one of the reasons that we're really excited about having multiple companies that have a capability to do what we want to do, we think we'll be okay there. You know, I have to remind everybody that NASA has not carried its astronauts to the International Space Station on shuttle for a number of years. After 2003 accident where we lost Columbia, the decision was made after depending on the Russians for a little bit more than 2 years to get our astronauts back and forth to the International Space Station, that would be our primary means of transporting crews for the International Space Station. And shuttle was used to transport if you will, the construction crews, the people that did the spacewalks and everything else to construct the International Space Station. So we're quite comfortable with that model. That's what we've been using now since 2003.
Thank you. So we have another question over here on the left.
Administrator Bolden.
Yes.
On your left.
Oh, that left.
Yes. Well, you talked of international collaboration. At NASA, are you worried about China overtaking you and India catching up very fast? They can do things cheaper and faster?
I would say no. We are encouraged by the progress that India, China, all the prospective international partners have been making. We actually have agreements with India, with the Indian Space Agency. We've been talking with them for some years, and we have the types of scientific endeavors going on with them that are mostly geared toward quality of life on the Earth. When I first met with the former head of the Indian Space Agency, you know, he told us very proudly that they had received a significant increase in their budget, but that 75% of their budget was dedicated, while they still want to get a human spaceflight program, 75% of their budget was dedicated to what they call human needs, to making life on Earth better. That's perfectly aligned with what we're trying to do and with what we're supposed to do in the national space policy.
Thank you.
Rohit Talwar from Fast Future in London. Two questions in one. Firstly, what's your view about what Europe should be doing in terms of its space program or its space policy? And secondly, how do you see the whole commercial exploitation of space playing out in the next 20 years? We have Virgin Galactic going to launch at some point, a lot of people talking about space mining, hotels in space, all sorts of possibilities. What's your view about how that might play out over the next 20 years or more?
The private development and commercial interest is something that we're very encouraged by. In fact, I think if you look inside NASA today and see what we're doing, we're signing what we call Space Act agreements, memoranda of understanding with private entities that can do things that need to be done to make it easier for us to do the deep space exploration that we want to be about, but cannot afford to do. If you talk about mining asteroids and the like, NASA's not interested in mining asteroids, but one thing we are definitely interested in, because we're required to do it under the National Space Policy, is to identify asteroids that are potential threats to Earth, and then work with the Department of Defense in ways that we can develop the technologies to either be able to deflect them or draw them out of the way, off course. You have to identify them first. And so, you know, we know that there are satellites that we can put on orbit, particularly around the planet Venus, that looks at Earth with the sun at its back. We'll pick up just about every asteroid that could possibly threaten Earth. That's a capability we don't have today. If private industry can do that with our cooperation, and we are agreeing with several entities right now to provide our technical expertise, our engineering expertise as these satellites are developed, then I think it's a win-win for the nation and the world, to be quite honest. You ask about Virgin Galactic. you don't have to go to orbit to benefit from being in space. NASA has been doing suborbital experimentation for decades. It's really encouraging to see that private industry now is going to enter into the suborbital business for profit, because a number of things are going to happen, hopefully. If they can get the cost down enough, some of you may one day have an opportunity to go to the edge of space, take a look at our planet as I've seen it, and understand the value of having people there. Also, it will mean that some companies that could not get time in suborbital space flight before for scientific development, whether it's pharmaceuticals, materials processing, or whatever, they'll have an opportunity to do that. When you talk about our relationship with Europe, ESA, the European Space Agency, has been an incredible partner for us for decades now. They have been with us throughout the development of the International Space Station. They remain with us now. ESA has been a big partner in many of our scientific endeavors. They're a partner with James Webb, with the James Webb Space Telescope. We're going to launch it on an Ariane out of Kourou. So those partnerships are long-standing and incredibly valuable to us.
Any further questions? There's a question down here in the front right.
Thank you, great speech. From an agriculture and climate change perspective, we need a lot more detailed resolution of what's happening with crops and with watersheds and so on. Can you tell us a bit about NASA's strategy to provide that detailed information so that we can build better models and identify difficult hotspots in a changing climate?
We have a number of Earth science experiments, Earth science satellites actually, that are on the drawing board, that are coming, that hopefully are going to increase the resolution that we have for Earth observing. I mentioned something called Surveyor. I'm not sure whether you're familiar with it or anybody else is, but Surveyor is a project that NASA works in cooperation with the U.S. Agency for International Development, where we take existing data, on-orbit data from Earth science satellites, most of them in what we call the A-train. I think it's 7 satellites right now that look at oceans, land, atmosphere, provide that data usually to an environmental center at one of, right now, 3 places in the world. The first one was in Panama, second one was in Nairobi, Kenya, and we just opened another one October of last year in Kathmandu, Nepal. And we have joined with the U.S. Agency for International Development with local environmental agencies that are looking at the kinds of things that you talk about. When I visited the Surveyor site in Nairobi, Kenya, it was just exciting to see science representatives from government, industry, and academia from 15 member nations in this environmental center in Nairobi, Kenya, who were there with American scientists learning how to build drought and flood models, so that region of the world could deal with the annual droughts and floods that come, but make it synergistic such that they don't, plan to deal with the flood and put stuff in place that makes it really bad for a drought. So those are the kinds of things that we're trying to do. And there are other projects on the drawing board. The big thing we have to do, though, is get funding. And so we continue to work with Congress to increase the emphasis on the need for Earth-sensing satellites. We continue to develop the new instruments that have the resolution that you talk about. Many of them we develop either for the U.S. Geological Survey or we develop for NOAA when it comes to climate and weather information. So that's our specialty, and we're trying to do more of it.
So we have a question from
right
your
there
left
and then over
there.
here, maybe. I think there's one right there. Do you have one here? Okay. And then there's a young lady over here also.
Thank you. Last year you were in South Africa. I'm from South Africa. I lead the Science and Technology Portfolio Committee in Parliament. You were there. We were hosting you on the Astronautical Federation and Congress. You explained something very interesting which inspired a lot of people that we talked to after that, especially the concept of understanding up and down in space and day and night in space. But particularly also, we learned that you have a joint mission now with our SANSA, this South African Space Agency, for a project of 2017. Can you explain what that would be?
I knew you were going to ask that. I'm going to have to find out for you. And I remember I met with Dr. Malinga, who's the head of the South African Space Agency. It is an earth science mission, the way that many of them are, but I don't remember the exact details of it. So I'll get it for you, and if you catch me here afterwards. My erstwhile international affairs folk down here are going to get on the wire and find it out for me. And he's going, am I really going to do that?
Niamh, we have a question down there.
You know, while we're going to the next question, I'll tell you, we not only met with the head of the South African Space Agency, but what was enriching to me was having an opportunity to meet with the heads of 5 African nations' space agencies. You know, most of you wouldn't think of space, science, and stuff like that when you think of the continent of Africa, because many of you, if you're like Americans, you think of Africa as a country. It's a humongous continent with many, 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 many countries of diverse interest. And most of them today are very interested in exactly what the gentleman was talking about over here. How do we better grow our crops? How do we deal with drought? And how do we deal with floods? And those are mainly the kinds of things that we're trying to work on, whether it's Nigeria or Algeria or South Africa or anybody else.
Charles,
yes.
There's a microphone down here to the right.
Oh, okay, now there. I'm sorry, and then we'll come back.
Thank you. It seems like there's been a lot of publicity again lately on the need for planetary defense and asteroid detection. So I had a 2-part question on that. Do you feel that the resources coming down the pike are adequate to address that? And secondly, do you feel that if there was a threat that was detected, that we would have sufficient time to develop, whether it's deflection or some other technology to address that threat?
The question she asked about planetary defense is one of critical importance. And, you know, there are many people who are becoming aware of the fact that Earth, it always has been threatened by asteroids and large particles and the like. But we haven't had the information available that we have today to let us know just how large the threat is. So we actually are involved even with private entities, in trying to see what kind of instruments are needed to enhance our ability to, 1, characterize what we call NEAs, near-Earth objects or near-Earth asteroids or whatever else you want to call them. Because the number 1 challenge is to find them. When President Obama challenged NASA to put a human on an asteroid in 2025, that sounds like an easy thing to do. Well, you know, asteroids are not like planets. They're not in a regular orbit around Earth, and they don't behave the way that we would like for them to behave. So one may come every 100 years or something else. So the first thing we've got to do is be able to look out there, find out which asteroids are in an orbit around the sun such that we can get to it in a reasonable amount of time. Second thing is we've got to make sure it's larger than your spaceship. Now that may sound trivial to you, but you can't land a spaceship on an asteroid that's smaller than the spaceship. We also have to know, when we talk about characterizing it, what is it? Is it sand? Is it metal? You know, will it be able to sustain just the weight of a human being, if that's what you're going to do, or the blast from a rocket as it settles on the surface to land? So these are things we have to do. Again, they cost money, and what is encouraging to me is that we now are finding that we can enter into agreements with private entities. One of the most recent ones we've done is a Space Act agreement with a group of entrepreneurs from the West Coast who are really, they've been approached by several people like former astronaut Rusty Schweigert, for example, who are really passionate about planetary defense. And they just want NASA's engineering expertise and scientific knowledge to collaborate with them as they build or buy a satellite that'll go into orbit around Venus and become something that we could use to identify and characterize the types of asteroids that we would want to be able to do something with. Our own space technology department is doing a number of, looking for people who will propose a number of different test missions where we can find out, okay, if we can identify an asteroid and we know what its makeup is, can we develop means to either deflect it such that all you need to do is move it, you know, by fractions of kilometers sometimes to have it have a huge misdistance of Earth. Some of you may pay attention to the International Space Station. International Space Station has stuff that's headed its way all the time, whether it's space junk or meteorites or anything. And we work very diligently to know the exact ephemeral data of whatever that thing happens to be. And it doesn't happen very often, but every once in a while, we'll have to change the altitude of the International Space Station to increase the mist distance. And it doesn't take a lot. You know, we don't move it miles, or we don't move it hundreds of kilometers. We can move it by small increments, and that drastically increases the projected mist distance. So I think I got both sides of your question. I hope I did. Okay? And I think there was one with the mic right here. Yes.
Hello. I'm wondering what aspects of space exploration would private companies be responsible for exactly? Are there any definite limitations on that? And specifically, would launching facilities, for example, ever be privatized, or would those always be in the province of NASA?
You know, what we're finding now, other than Cape Canaveral and Vandenberg Air Force Base, many of the launch facilities that are starting to take birth, if you will, are the purview of states, you know, independent states in the United States. So there are federal launch sites, but states themselves are forming space agencies or space commissions and trying to attract commercial entities to launch out of those sites. So it doesn't have to be a federal launch site to be there. From my perspective as the NASA administrator, wanting to get maximum utilization out of your facilities, I want everybody who's going to send humans to space to launch out of the Kennedy Space Center. You know, I want them on Launch Complex 39 because I have what I think is the world's greatest launch complex for human-carrying vehicles, and I would just rather have them there than anywhere else. But I don't know what the future is going to bring. But we're going to do everything we can to make our facility available to everybody and attractive to do that. So, so that's kind of where we are with reference to the burgeoning, you know, commercial entities that are coming about. They've got a hard road ahead. You know, I love to see the interest and the enthusiasm that everybody has, but what we do is hard. You know, if everybody could do it, it would have been done decades ago. But everybody can't. When you talk about what's the role of commercial space in exploration, I have to remind everyone, NASA doesn't build rockets. We put some sounding rockets up every once in a while. From Mercury, Gemini, Apollo, those were pretty much built by American companies, by private companies. Granted, in the public domain because they had shareholders, but not built by NASA. They were built in collaboration between NASA and industry. And that's really what we're about to do now. We're going to collaborate with SpaceX. We're going to collaborate with Orbital. We're going to collaborate with Boeing. We're going to collaborate with any company that wins a contract. And we'll, as I mentioned to one of the questions earlier, provide them with the requirements that we need to certify it for human use, just as we've always done. And we're going to monitor and watch them and make sure that they build it to our requirements. And until it's done, then we don't say it's ready to go. With Dragon, that went to the International Space Station. It took them a little bit longer than they thought because in order to visit, we didn't put any requirements on them in constructing the Dragon module. But in order to close with the International Space Station, the international partners have a set of standards that we call visiting vehicle requirements. And they are mainly to protect the International Space Station. In doing so, they protect the visiting vehicle itself. But until you can meet the visiting vehicle requirements, we don't let you get in a bubble around the International Space Station. And so there were a number of things that, you know, in the case of SpaceX, that they just weren't far enough along on it. So, you know, we helped them to get to the point where they could meet all the visiting vehicle requirements and then get ready to go. Orbital will have to do the same thing when they go. And my guess is that they'll fly a very similar profile to what SpaceX did, which is to launch, rendezvous with the International Space Station, find it, and then demonstrate that you can get close to it, but not too close, that you can maneuver to move away from it or some other place to approach it, and then let us look at all the data along with them. And once we're all satisfied that they can do that, then we let them close to within what we call grapple range of the station, which is 10 meters. I mean, pretty close. And then they stabilize, and after that, we tell them, okay, you go hands off. We don't need your help anymore. And then the onboard crew of the International Space Station uses a Canadian-built, the Canadarm, to reach out, grapple it, and then berth it to the International Space Station. Okay.
So there's a question up the back.
Okay.
Give somebody up the back a
yes.
chance. Can we get a mic to the hand?
Right here. And are there questions up there? Yeah, I'm seeing it. Okay, if you have the mic, go ahead. Just yell so I'll know where you are.
There's a
I
gentleman,
know there's a gentleman over here in a blue shirt and one right here. Whoop. We'll get her back over there.
Can I use the mic?
Yes. Where are you? Oh, right up. Are you up?
Where are you?
I'm closer.
Oh, closer, right here. I got you. I'm sorry. We're busy looking up there.
My question is rather controversial.
That's good.
I would like you to comment on the UFO phenomenon. And basically, what is the official state, what is the official position, and what are the speculations that you are aware of? Could you please comment a little bit on that?
UFOs are interesting because UFOs exist. We see UFOs all the time. A UFO is an unidentified flying object. It's anything that comes into your field of view that you don't know what it is. So far, as far as I know, we've been able to identify the source or the origin of every unidentified flying object. Every once in a while, you'll hear a story that hits the mainstream media, or sometimes non-mainstream media a lot. Some dramatic story about, a spaceship, an alien ship that landed in somebody's backyard or something. We don't know about it. We have not been able to verify any of the reported stories of extraterrestrial vehicles coming, and landing on Earth or hovering over things on Earth. But those stories happen all the time. We do have, I'll give you an example of UFOs that we report from shuttle and station. On my very first flight, we saw an object float up from the back of the shuttle, and it just kind of hovered there for a while. So we said, okay, got something here. We have no idea what it is. As far as we can tell with the binoculars and everything, we haven't lost anything off the back of the orbiter. Turned out it was a very simple answer. When the space shuttle sits on the launch pad, the liquid hydrogen and liquid oxygen, the propellants that go into the main engine, are really, really cold. I mean, super cold. And when they flow in, when the vehicle is loaded, when they flow into the external tank and then into the vehicle, the back end of the shuttle, where the three main engines go in, get really cold. And if it's a nice humid day on launch morning, you've got just a whole big sheet of ice back there in between the main engines. And I mean, it's really thick ice. When you launch, some of it gets shaken and shakes apart. If any of it goes to space with you, which a lot of it does, eventually it does something called sublimation. It goes from the solid state right to gaseous state. But as that happens, some big chunks of it come loose. And because you're in space where gravity is overcome, they don't just fly away like they would down here on Earth. They just kind of start floating around out there, and they stay with you for a little while, and they'll follow you around, and it causes you to wonder what it is, and it turns out it's ice. So that's an example of a UFO. And I'm not trying to make light of what you said at all. And it's not a controversial question at all. It's a question of things that we can identify factually versus things that we have not seen, have no evidence of, and we just have somebody's, an unidentified observer or an anonymous observer's report and a photo that we have no way to verify and document. So far, we've not been able to verify anything that's been classified as the kind of UFO that makes the front page of sensational magazines and the like.
So we have a question on the back left.
Oh, back left?
Left.
Yeah. Thank you for the fascinating perspective you are giving today. You are describing a future where multiple commercial entities operate in space. I wonder if you at NASA are working on providing a legal framework for these commercial entities interact in space, like in international waters, for instance.
What's the policy we're working on right now? Huh? No, not the code of conduct, but there's another. I'm sorry, because about commercial space and national space transportation policy. Even as we speak, we're working on something that's called the National Space Transportation Policy. And its purpose is the start of what you're talking about, to make sure that there's a framework in which anybody that goes into space has to operate. The United Nations has an effort underway, a code of conduct for operating in space, where they're trying to get their member nations to agree that, one, I won't do anything hostile in space. Two, I won't do anything to damage the satellite or a system of somebody else. And it defines how you should behave in space. So there are efforts underway all over the place. NASA is we're not a regulatory agency, so we abide by the developed regulations and policies, and we have input into them, as they're developed, but we don't actually develop the regulations.
Okay, I think we've time for one final question, and I think that's going to be eeny, meeny, miny, mo over here.
I just wonder, could you comment on NASA's plans for Mars? I mean, you've been incredibly successful with your robotic program. The vision for space exploration seemed to specify a quite clear program for human exploration of Mars. And I'm wondering, is that still a priority for NASA?
For NASA, because the president has it as a priority, it's a real priority. President Obama has said very clearly, he wants humans on Mars in the mid-2030s. He wants us on an asteroid in 2025. And our task right now is to work with our international partners, with other agencies, to find a way to do that within there's one thing that always messes you up when you want to do things like we do: money, budget. So because our budget has, like every other budget around the world, has changed dramatically from what it was when President Obama came into office, we now have had to look at what does our long-term spending availability look like. And so it's caused us to step back for a moment, and we're actually doing it in collaboration with our European partners and others. We're taking a step back saying, okay, how do we, with the funding that we see we're going to have available, how do we get humans to Mars by the mid-2030s? Because we can't do some of the things we needed to do. There are a number of challenges, and somebody mentioned it earlier. Radiation, how do we protect the crews? Mars itself, is it safe? Is it hostile to life? Can life exist there? So that means, as the National Research Council in the United States said, the #1 priority for the Planetary Decadal Survey from the National Research Council is a Mars sample return mission. That can be a very, very, very expensive mission that could eat up your whole Mars budget, if you allowed it to. So we're now looking at innovative ways to use robotics, to use robotic precursors. If there's commercial data available, which there is not right now, if there are other nations who are doing similar things to what we would like to do, if we can't collaborate with them, can we find a way to get them to let us use the data? So our Mars program is, while not well-defined, the trajectory that it's on is very well-defined. And it has some very definitive dates. Humans on Mars by 2030. The most important thing that's going to happen on the road to Mars with humans by 2030 is going to happen on August 6th, Pasadena time. And that's the safe landing of the Mars Science Laboratory, the Curiosity module, the Curiosity rover. It is huge. It's the size of a Mini Cooper or a Volkswagen. It's the largest vehicle that America has ever sent anywhere, other than what we sent to the moon, and tried to land. It's the largest one we've ever sent to Mars. And it's got a very complicated atmospheric entry process, and then the landing itself we've never done before. We have never done a controlled landing, a very tightly, in a very constrained area at the base of a mountain in the middle of a crater. We're going to use a crane. We're going to take it into the Martian atmosphere. It'll use its heat shield to create a lot of drag and slow it down a little bit, then deploy a huge parachute. We just hope there's enough air for it to be good, and that'll slow it down some more. And then as it gets closer to the surface, say several hundred meters, we'll start firing, people call them retro rockets, that'll slow the descent of the lander until it stops, it stabilizes. And then when that happens, you're going to do something really simple. It's going to be a cable. 4 cables, in fact, that are attached to the rover, to Curiosity. They're going to gently lower it to the Martian surface. There'll be sensors that'll detect when it's down. The cables will be cut at the rover itself, and so the lander will fly away. We affectionately call it 7 minutes of terror, because the communications lag between here and Mars is about 7 minutes. So we're going to look at our watches, and at the appointed minute, everybody will start holding their breath. And 7 minutes later, we can breathe, we hope, because you'll get the data that says, okay, 7 minutes ago, Curiosity safely landed on the planet, and it's ready to start going through its deployment activity, which is put its big antenna out, put the big, well, I forget what we call it. It's like, it's got cameras on it. And those of you who know about James Cameron for Avatar, the cameras on the Mars Science Laboratory on Curiosity are the product of James Cameron's commercial enterprise. He's got 2 monocular cameras that he has software that's going to make it give us 3D images, high definition, color, 3-dimensional images from the Martian surface, and that's going to be absolutely spectacular. People have fallen in love with the imagery that NASA's been showing here over the last few weeks from the Opportunity rover, from the couple of years that Opportunity has been going around it. You know, it looks at the Martian panorama, and it's breathtaking. You're going to see stuff that's even more spectacular than that come the 5th of August. So we're excited, we're scared, but we are really excited. So that's it in a nutshell. Thank you all very much for allowing me to spend time with you. It's been great. Thank you.
So thank you very much, Administrator Bolden. Unfortunately, the ex-astronaut has to eat dinner at some point. I think the next time we invite him back, we'll invite him back for about 3 days so we can continue these kind of conversations. But I'd like to thank him once more for making the suborbital flight to Ireland to give his presentation. Thank you.